for lesson 7, the last lesson of our ratios unit, we will be discussing ratios on the coordinate plane. So to start, ratios can be represented in multiple ways. The first one is tables. Then we've done graphs. We've done equations. We just saw some of these in our last lesson. We can do this on the coordinate plane, which is similar to graphing. And finally, with what's called a verbal description. That literally just means to write the story of the problem in words. Okay, so in our first example, we're going to turn the graph into the table and then use all of that to figure out the verbal description and the equation down below for this whole situation. So I see we have a graph and I can see the points. It's like 1 to 50, 2 to 100, 3 to 150, 4 to 200. And when I pop over here to my table, I see that point is in my table, 4 to 200. So basically all these points just need to be put into this table. So we're going to have 1 to 50, so 1, 50, 2 to 100, 3 to 150. And now as I'm looking at this, I'm going to check out the process and see if there's a pattern here. To get from 1 to 50, that would be 1 times 50. Remember, you can use the X or the dot for multiply. We're changing over to the dot very soon, so that's why I'm using it. 2 times 50 would be 100. 3 times 50 is 150. 4 times 50 is 200. So that's working out. Let's keep going. 5, 6, 7, 8, 9. Just counting by ones there to keep the pattern going. So 5 times 50, 6 times 50, 7 times 50, 8 times 50, and 9 times 50. We can see over here that these values are the ones that we're going to need for our other column, or we could just skip count, which is probably faster. So 50, 100, 150, 200, 250, 300, 350, 400, 450. And just to double check that that last column worked out, 450 and 9 is exactly what we had, so it's perfect. So there it is. Now we can write our equation. So to get from hours to miles, we do times 50. So H for hours times 50 equals M for miles. Or the fancy way, if you'd like, M equals 50H, meaning M equals 50 times H. Okay? Now here's the situation. We need to write a story for this. Like, what is happening? What is happening in these hours, turning it into miles? It's making me think of a car driving, like miles per hour. So I'm going to say a car travels, and we've got, let's pick a ratio here. How about just the first one because it's easiest? 50 miles in 1 hour. Or if you wanted, you could say every hour, or you could fill in any other entry on the table. You could have said 200 miles in 4 hours if you wanted to. Doesn't matter. I'm just using the first one because we chatted in the last lesson about how the number 1 is super important for ratios. All right, so let's take a look at some of these problems. What is the ratio of the number of hours to the number of miles? Well, that's easy. We actually just wrote it in our verbal description. And we can grab it right from our first entry in the table. So the ratio is 1 hour to 50 miles. It would not be wrong to choose literally any entry in this table. So you could say 7 to 350. Okay, it doesn't matter, your choice. How many hours will it take to travel 300 miles? Well, let's see if we have 300 in our miles column. I see it right here. 300 miles is 6 hours. If this continued with the same ratio, then how many miles would be traveled in 15 hours? I don't see 15 in our hours column, so that tells me that what we're going to have to do is a proportion. So I'm going to write my ratio from number 1, 1 over 50. But in real life now we're asking about 15 hours, not 1 hour. So I'm going to change it to a 15 on the top. And now we just have to say, how do you get from 1 to 15? Times 15. Do the same thing on the bottom so that it stays equal. And then off to the side here, 50 times 15. 750. Okay, so 750 miles because we were finding the number on the bottom. Last one. What does the ordered pair 9, 450 represent in this situation? Well, let's get the labels. The 9 is hours and the 450 is miles. So that means in 9 hours, the car travels 450 miles. So all I did was take the number and then add on its unit from the table. For our next example, we're going to try to fill out this graph and the table and the equation from our verbal description. So I'm going to start with filling in my table. Bike rider graphs his training for the week. He trains by riding 5 miles each day. And we had discussed in the last video, each day means 1 day. So 1 day goes with 5 miles. Okay? Our process here should be quick because it's going to be 1 times 5 equals 5. And I see our labels here for days just count by ones. So I'm going to just count by ones. And I can fit up to 7. So that's what I'm going to do. And now just follow your process. 2 times 5, 3 times 5, 4 times 5, 5 times 5, 6 times 5, and 7 times 5. And honestly, I'm going to do a couple, and then we're going to skip counts. So 2 times 5 is 10, 3 times 5 is 15, and now I see it. 5, 10, 15, 20, 25, 30, 35. Didn't need to do all the multiplication. Perfect. All right, let's do the equation quick. So we're going to take the days, right? We're going to do times 5, and that gives us the miles, okay? So we're going to say D times 5 equals M. If you want the fancy way, M equals 5D. Now, we have a graph that's nice and labeled for us, so I think it's going to be pretty quick to plot this. So remember, your first column is X, your second column, your last column is always Y. We don't consider the process column when we're plotting. So X is 1, Y is 5. So over to the 1, up to the 5. 2 and 10. So 2, 10. 3 and 15. I can see the pattern now, so I'm just going to plot the ones we had. And my last one there was 7, 35. Okay, if you want, you can connect it. There it goes. Label it with your equation. D times 5 equals M. And there you have it. For our last example, we have a graph and a table. I see on the table that I do have an entry that has 2 numbers, so I can actually use that to find my process. I'm not sure how many times 5 goes into 60, so I'm going to just do long division quick. So I'm taking 60 and dividing it by 5. So it looks like it's 5 times 12. So there you go. You've got your key number for this entire problem. It's the 12. So 1 times 12, 3 times 12, 4 times 12, 5 times 12, and then we jump all the way to 8 times 12. So if you notice, this part, we're not skip counting because we're skipping steps. We skipped the 2 and we skipped the 6 and the 7. So just manually multiply so that you don't make any mistakes. 1 times 12 is 12. 3 times 12 is 36. 4 times 12 is 48. 5 times 12 was 60. And 8 times 12 is 96. If you weren't sure about that, you could write the multiplication out on the side. Okay, those are actually the exact same 5 points that we have on our graph. And you can see how on the graph they skip spaces. So that's how you know that skip counting isn't going to work because we're missing some kind of in-between points. All right, how about an equation? We take the hours and we do times 12 to turn it into the number of parts. So H times 12 equals P, or a fancy way, P equals 12H. Now, we're talking about some situation where over some amount of hours, we get a certain amount of parts. So I'm thinking for my verbal description, my story, I'm going to say a company sells 60 parts in 5 hours. Again, it is entirely your choice which numbers you want to use for your verbal description. I chose this row here. You could choose the row with the number 1. That would not ever be a bad idea because the number 1 is always the most simplified version of a ratio. But I chose the 50 or the 5 with the 60 just to show you a different way to write it.